Hello, my name is Allison Brown, and this is a presentation of Paired Samples T-Test for Curriculum 7002, Applied Statistical Analysis. The purpose of this presentation is to answer the following questions. What is the Paired Samples T-Test? When is it appropriate to use the Paired Samples T-Test? What are the assumptions that must be met before a researcher can conduct this test? How do we run and interpret a paired samples t-test? The paired samples t-test is a parametric hypothesis test that allows researchers to compare two means that are from the same individual, object, related unit, or group. The purpose of the paired samples t-test, often called a dependent samples t-test, is to determine whether there is statistical evidence that the mean difference between paired observations on a particular outcome is significantly different from zero. In other words, a paired samples t-test compares two sample means from the same population regarding the same variable at two different times to determine whether the difference between the two means is statistically significant or occurred by chance alone. Statistical significance within the paired samples t-test is determined by looking at the p-value. The p-value gives the probability of observing the test results under the null hypothesis. The lower the p-value, the lower the support for the null hypothesis. Usually the cutoff value for determining statistical significance is 0.05 or less. This corresponds to a 5% or less chance of obtaining a result that supports that the null hypothesis was true. Figure 5 shows the formula for the paired samples t-test, where the numerator is the mean difference of the paired data and the denominator is the standard error of difference. Another important characteristic of the paired samples t-test is that it must have one dependent variable that is measured on an interval or ratio scale and one categorical variable that has only two related groups. The paired samples or dependent t-test is used for within subjects or matched pairs designs in which observations in the groups are linked. The linkage could be based on repeated measures, natural pairings such as mothers and daughters, or pairings created by the experimenter. Some other examples of when this may occur are before and after observations on the same subjects. For example, students' diagnostic test results before and after a particular modular course, or a comparison of two different methods of measurement or two different treatments where the measurements or treatments are applied to the same subjects. To recap, it is appropriate to use the paired samples t-test whenever two distributions of a dependent variable are highly correlated. This could be either because they are distributions of pre- and post-test of the same subjects, or from two samples that are matched, such that there is a one-to-one correspondence between each subject in Group 1 and its matched pair in Group 2. Before we look at the details of how to perform and interpret a t-test, it's a good idea to understand the assumptions underlying the use of the t-test. One of the first and most obvious assumptions in the paired samples t-test is that only the matched pair can be used to perform the paired samples t-test. Some additional assumptions: the data is normally distributed and continuous. The dependent variable is normally distributed in the two conditions. The variances between the groups are equal. The sample size is adequate. The data is measured on an interval ratio scale. Observations must be independent of each other, and observations for each pair should be made under the same conditions. So before we carry out any t-test, we must check to make sure that the data satisfies all of these assumptions. However, if the data seriously violates any of these assumptions, then non-parametric test should be used. To display the process of completing a paired samples t-test in SPSS, mock data was used where the hypothesis is there is a significant difference between the pre and post test, and the null hypothesis is that there is no significant difference between the pre and post test. The first step in this process is to enter or upload the data into the SPSS platform. The data should include two variables that will be used in the analysis. The two variables should represent the paired variables for each subject. To run a paired samples t-test, click Analyze, Compare Means, and then Paired Samples t-test. This allows the paired samples t-test window to appear. This is where you will specify the variables that are going to be used in the analysis. All of the variables will appear in a list on the left side. You will then move those variables to the right by selecting them in the list and clicking on the arrow buttons. The SPSS output will consist of the paired samples statistics, the paired samples correlations, and the paired samples test results. The focus areas are circled in red. The first area shows the means that are being compared, and the second area shows the t-test and its statistical significance. Seen as statistical significance is determined by looking at the p-value, in this case, the significance two-tailed area, and that the p-value is set at 0.05. This paired samples t-test indicates that the pre-test scores and the post-test scores are significantly different. This result of 0.027 means that the null hypothesis will be rejected. In summary, the paired samples t-test is used in hypothesis testing to determine if there is a significant difference between the means of two matched variables. For more information, you can refer to this additional resource entitled SPSS for Beginners Paired Samples t-test. This YouTube tutorial presented by Dr. Todd Daniel shows researchers how to conduct and interpret a paired samples t-test in SPSS. As a quick review of paired samples t-test, let's play a game of Question number 1. The purpose of the paired samples t-test is to determine whether there is a statistically significant difference between the means of the independent observations, true or false. Question number 2. It is appropriate to conduct a paired samples t-test whenever two distributions of a dependent variable are highly correlated, true or false. No p-value suggests that the hypothesis is not true, and that the difference between the measurement pairs is not zero, true or false. Thank you for listening to this presentation of Paired Samples t-test.